Hi friends, now let's look at some drawbacks of using log for synchronization purpose. The most important drawback using log is waiting process keeps using the CPU time. That means when we say a process to wait because log is not available, then it will be running the CPU or it is using CPU time, so it will be in the running state. So for example, if we take this two examples, one using test and set, other using swap. So what is happening is, if one process is already using the log, if one process has logged for the critical section, then any other process, if it wants to enter the critical section, must use the log. So as we discussed in our previous two sessions, test and set and swap, what happens is the other process, if it tries to use the log, will be held in this while loop till a log becomes free. Same thing with the swap. So as long as the log is free, the key value will remain true, and while the key value is true, this keeps swapping. So unnecessarily the value is being swapped between the two. One is log, other is key, and in this case both are 1. Therefore just keeping the same values but swapping. So this one copied here, this one copied there, this one copied here, that one copied there. So this keeps on doing, and this is done by the CPU. And as long as the process is in this while loop, definitely the CPU is being used because the process is in the running state. We did not change the state of the process, because we did not change the state of the process from running to either ready or waiting or anything, but we made it to wait. So the CPU is still being used and it is running this. It checks test and set, busy, so test and set, busy, so check it, busy, so check again, busy, check again, busy. Or this side, swap and check what is log, busy, okay, swap again, what is log, busy, swap again, what is log, busy, and that's. So what is happening here is the wastage of the CPU time. So we are unnecessarily wasting the CPU time, because we know that till the process which is in the critical section comes out of the critical section, it cannot release the log, and till the log is released, the current process cannot enter the critical section, or the current process cannot continue any meaningful execution. It's just doing a nonsense execution, waiting and waiting and waiting and waiting. It's just meaningless. What to do? And what is problem? The problem is CPU utilization, throughput, everything goes down. Unnecessarily you are wasting time of the CPU. Instead of keeping CPU busy for this nonsense acts, you could have given the CPU time to some other process which is ready to run, which don't want to use that particular shared resource, want to run without that shared resource. Therefore it can be allowed to continue, so that other process can get into the running state, and then, but since this process is in the running state, the other process cannot get into running state, and that's so wastage of the CPU time. So CPU utilization goes down, the throughput goes down, and all that. And this is what waiting and spinning around the log, what we call is a spin log. So here what is actually happening is a process is spinning around the log and waiting for that log to open, So every now and then just keeps watching whether lock is open or not, lock is open or not, lock is open or not. The moment lock is open, it wants to enter it, but sees most of the time that lock is not open. Therefore, it is waiting there, and in that, what is happening is it is unnecessarily making CPU to run and say that wait, wait, wait. What CPU is doing? Nothing. It could have done some meaningful work, but it is not allowed to do any meaningful work because these two while loops are putting that into an almost indefinite loop, and this is being executed again and again and again by the CPU, and hence with no result CPU is being used, and the CPU time is very precious and we are wasting it, and definitely it's going to be a big drawback for the CPU utilization or throughputs are concerned. So what is the solution? The solution is not to make them wait for the lock. When you realize that one process wants to enter the critical section, so it has to see the lock, and once it sees the lock, instead of waiting for the lock to open, why not stop executing currently? Why not just pause the execution and after some time try again? So this pausing the execution is what we say block the process. Instead of waiting here indefinitely, why not block it? Don't keep it in the ready list. A process, say PI, wants to enter critical section, and at that time log is not available, which means PI cannot use the shared resource. So if PI cannot use the shared resource, what should PI do? So instead of getting back into the ready state where there is possibility that the scheduler next time again PI will be allotted, and PI finds that there is no shared resource available, so it again continues. So we are wasting CPU time, we are keeping it in ready state. Instead of keeping that in ready state, why not block that process, dump that onto the block list, and when the lock is open, then move that process from the block list to the ready list, and that's what is more appropriate. So that way what happens is that process which is waiting for the lock to be released is no more in the running state, and it gets into the block state, and hence no more CPU runs for that process, and hence no more wastage of CPU time, no more spin lock, no more reduction in the CPU utilization, throughput and all that. Yeah, that's what is required. But how to do a lock arrangement? What we have seen, the two methods are not going to solve this problem, but we need something else, and that something else is what we call either semaphores or monitors. So semaphore is a mechanism where it makes the process to get blocked till somebody raises it. So what happens? What is expected now is one process wants to enter critical section and finds that cannot enter the critical section, then instead of being in the running state or the ready state, get down to the sleep state. And when that shared resource for which this sleeping process was waiting, when that shared resource is available, that time someone can wake this process and say that the one which you were looking for is available, can go and use it. So as example, if you want to look at this, is like a waiting in the queue for your turn to come. So keep waiting and waiting and waiting till you reach the window, But instead of that, we could have given some token numbers or something so we can relaxedly sit somewhere, and when the token is announced, just go there, get our work done, instead of standing in the queue before the window and looking at the window and waiting for your turn to come. Why not go and sit relaxedly and wait for someone to call you that it is your turn now? Yeah, that's what this semaphore or monitors are going to do. How they do, we look into our coming sessions, so please keep watching them, and don't forget to like, comment, share with your friends, and please do subscribe to this channel. Thank you.